Hello, Math 30-1. Now, in today's lesson of functions and relations, we're going to be learning about the inverse of a relation, okay? So here are some things to remember. Now, when we're looking at inverse, that means our domain becomes our range, and our range becomes the domain. They're switched, okay? Also, the inverse of a function may not be a function. It may be only a relation, all right? So here we go. Let's look at example number 1. It says, consider this following equation, which makes a graph of a circle, whose center is 3, 0 and has a radius of 3. So let's try and make this out here. So my center is 0, and I have a radius of 3. So I go from there, to there, and I'm going to go to here. So I'm going to now make this graph, try my best to make a circle. I'm not the best drawer. And I get something that looks like that. That's close to a circle, okay? Now it says, describe how to use the graph of the relation to draw the graph of the inverse. Well, how do I make the graph of the inverse for this? Well, it's simple. I am going to have to reflect it, do a reflection, we learned this last class, reflection on the line x equals y, okay? So, we'd have to do a reflection along this line here. And I'm just going to, on that line right there, we have to do a reflection. Hopefully you can see a little bit, I don't want it too dark. Just a reflection on that line. Now it says, sketch the graph of the relation and its inverse. Now remember, this here is a relation. Why is this a relation? This is a relation because straight line test. That's the easiest way. You could do the vertical line test that we learned in grade 10. So it says sketch the inverse of this relation. Well, I want a reflection in this. So this point here looks to be shared. Then it's going to go over here because this point is 1, 2, 3 away. So we have to go 1, 2, 3. So it's going to be there. So we have a point here. This point here is 1, 2, 3. So we're going to have to go 1, 2, 3, and so on and so forth. So my next one is 3 down, and then we have that point there. So my new graph is going to look like this. Okay, so there's my inverse. Now it says, describe how to use the equation of the relation to determine the equation of the inverse. Well, all I have to do is we interchange x and y. So we're going to switch or interchange x and y. Okay? That's it. So it says, determine now the equation of the inverse. But we want it in this form. All right, first thing we must do is we must switch x and y. So I'm going to be left with y subtract 3 squared plus x squared is equal to 9. But here it wants the x one first, right? So I'm going to redo that, and I'm going to have x squared plus bracket y subtract 3 squared is equal to 9. Okay? And there, and it wants this to be in, the r should be in root squared, so I'm going to, 9 is the same as 3 squared, so I'm going to switch that up a bit. Because 9 is actually equal to 3 squared, because this wants r squared. So I square root of that, just puts it, makes the equation happen. Next part says, write the equation of the inverse, d. Okay, so by solving for y, so we want to put it so we can make it in our graphing calculator. Anytime we want to put an equation in our graphing calculator, we have to make it y equals. So we're just going to solve for y. So let's solve for y here. First thing, I'm going to have to move this x over to that side. So I'm going to be left with y subtract 3 is equal to 3 squared minus, and we have x squared. Okay? Now let's do that. Oh, and this is all squared. Now I'm going to take the square root of that. So I'm going to be left with y subtract 3. If I square root both sides, I'm going to be left with, I'm going to leave it at 9 now, subtract x squared, and we square root that. And then I have to plus 3 to both sides. So that's going to give me, as my final answer over here, we're going to be left with y is equal to square root of 9 subtract x squared, and then we have to plus 3 on the outside. And that's going to be my equation. Okay? Now, f says, state the domain and range of the relationship. Okay, so we want to know the domain and range of the original function and the domain and range of my inverse. Let's start, we're going to do original. Okay? Okay, so let's do here my domain. Well, my domain, we're going to be looking at x, such that. Let's take a look at my original. I could go all the way this way and all the way that way. So the minimum I could go is 3, negative 3. Okay? Now, x could be equal or greater to that, because that's the farthest over in this graph I could go, is this way. And the largest I could go is 3. Okay? And we have x is an element of all real numbers. Okay? So normally, the fastest way of doing this is putting x in the middle. I'll do it for the y to show you how I like to do it the best. So now we're going to look at y. And we're looking at y such that y is an element of what? So let's try and solve this out here. Now I take a look at this. Here's my y values. I'm looking at y. Okay? And I'm saying y is greater than or equal to something and less than or equal to something. Well, what's the smallest y could be? 0. And it could be equal to it, so I'm going to leave that as is. I don't have to erase it. What's the biggest y could be? 6. I'm looking at y, such that y is an element of all real numbers. Okay? And there's my y. Now, let's take a look at my inverse. Okay? Let's first do my domain. Okay, my domain here. We're looking at my x. So x such that, and I'm just going to put this here, x, put my little boundaries, because where is x in between? I look at it, my minimum is first, is going to be 0. My maximum is 6. And x is an element of all real numbers. And my range here, we're going to look at y. And what is my range, my minimum? Oh, put y. What's my minimum for my range? My minimum range is right there. My minimum range is negative 3. My maximum range, my maximum height is 3. And we're looking at y such that y is an element of all real numbers. And that's it. And if I look at this one here, my domain and my range. For the inverse to the range, look at this. My domain and range there. The domain and ranges are switched. And that is it. Okay. So here are the steps to follow. I strongly suggest highlighting these steps on how to solve for inverses. So now it's telling us, find the inverse of the following. So we want to find the inverse of f of x. So first thing I'm going to do is step 1, replace f of x with y. So I'm going to end up getting y is equal to 2x subtract 3. Okay? Now I'm going to interchange x and y, because that's what inverse means. Our x becomes y's and our y's become x. Our domain becomes range and our range becomes domain. All right? So I have x is equal to 2y subtract 3. Now we're going to solve for y. So I'm going to add 3 to both sides. So I get x plus 3 is equal to 2y. Now I'm going to divide both sides by 2 as I said for y. So I get x plus 3 over 2 is equal to y. There we go, solve for y. Last step is I have to replace y with the inverse sign. Okay? So let's replace y with my inverse sign. So I get f, this means inverse, okay? Doesn't mean reciprocal, negative reciprocal, no, it just means inverse. The inverse of x is equal to x plus 3 divided by 2. That's my inverse. Do not get this confused as reciprocal. This here does not mean f negative 1 of x does not mean 1 over f of x. Okay? This is not true. Do not do that. I've seen students do that before. Do not do that. Okay? They are not the same. It's a common error that students make. All right. Let's take a look at the next one. So, step 1 again. What are we going to do? Replace f of x with y. So we get y is equal to x to the 3 plus 4. Now, we're going to interchange x and y. All right? So I'm going to have x is equal to y cubed plus 4. See why we kind of did that function of function first, putting in stuff, because x and y interchange. We'll get to that later. Now, what we're going to have to do is solve for y. So I'm going to subtract 4 from both sides, so I get x subtract 4, right? Subtract 4 from both sides is equal to y cubed. My next step here is, well, I'm going to have to cube root. Cube root. Cube root. Right? We're using BIDMAS in opposite order because we're isolating a variable. Okay, so I'm going to get x subtract 4, cube root of it is equal to y. Now my last step is switch y with the inverse of f of x. So I go f x is equal to the cube root of x subtract 4. And that is it. We are done. Okay? And it's cube root of all of this there. Maybe put in brackets just so it looks better. Okay? Alright, let's try example number 3 now. It says, consider this following function. Step 1 is graph the function on the grid and provide a domain and range. So let's first graph the function. So we want x squared, and then we're going to subtract 4. Alright, so x squared subtract 4. So this is my y-intercept is -4, which is right there. And now we want x squared. So 1 squared, minus 4, 1 squared is, we go up 1, doesn't matter if it's negative or positive 1, we're going to go up 1, okay, so that's there, 2 squared, oh, these are counting by 2's here, aren't they? So I'm going to go, 2 squared is 4, so 0, 0, so I have there, okay, let's try 4 squared, it's 16, minus 4 is 10, so my next one is there, and then there, because it's counting, if we look at these, they're counting by 2's. And now I'm just going to connect this. Okay? And it goes up. So, find my domain and range. Okay? So my domain is all x numbers. We're going to look at x, okay, is an element of all real numbers. Because it goes forever this way and forever that way. Now, let's look at my range. So we want to look at y. I'm going to set it up this way again. Okay? And we're looking at y such that we have y. Okay? Now, I look at this. Is there a minimum of y? Yes, my minimum is -4. Is there a maximum to y? No, y goes forever up. So there is no maximum of how high we can go. So y is just greater than or equal to -4. And we have y as an element of all real numbers. That's it. Okay? Now it says determine the inverse. So we're switching this. This is another fancy schmancy way of saying inverse. Look, it says we're switching that y is an x. Okay? So let's try and solve for this one now. Okay, so we have y is equal to x squared minus 4. Now we must interswitch x and y. So we're going to end up getting x is equal to y squared minus 4. Okay? Now I'm going to move the 4 on that side by the x, because we want y by itself. Plus 4, so I get x plus 4 is equal to y squared. Continue solving for y. I end up getting square root of both sides. I end up getting y is equal to square root of x plus 4. Now, it wants to say f of y. Okay? Is equal to x. So then, let's put that in. So my solution is just this, and it's going to be plus or minus. Anytime we have that is actually plus or minus the square root. Okay? So we continue that. And that's it. Because we have it in terms of y. Just as to solve for y. Next part here, it says graph the inverse of the function. Should turn this